In this recording, we're going to continue to look at characteristics of quadratic functions, specifically max and mins and end behaviors and when the function is increasing and decreasing, characteristics like that. So let's start out by looking at the gizmo. This is the gizmo where we can get to see the effects of the parameters a, b, and c here. So the question we see on our notes sheet here is, when does the graph open upward or downward? I think you know the answer to this question, but let's just confirm that. C is the constant here. That controls the y-intercept, right? Wherever I put C, that's where the graph's going to cross the y-axis, because that's when x equals 0. B is kind of a weird parameter. It kind of slides this parabola around in a parabolic that moves the vertex in a parabolic arc, oddly. And A has the effect of making the graph very narrow, all right, really stretching it vertically, or making it very wide. And if we make A negative, of course that flips it over. It reflects it across the x-axis. All right, so let's make a note of what we just discovered. Obviously, this is a little review from your transformations. It opens upward whenever A is greater than 0, and the graph opens downward whenever A is less than 0. Okay. What I'd like you to do here, I think you know a lot of these characteristics and domain and range, etc. I'd like you to pause, do as many of these as you know, and then play the recording when you're ready for some feedback. All right, for the axis of symmetry, because it's in standard form, we're going to apply this axis of symmetry formula. So we're going to write out x equals negative b over 2a. Okay, and so in this case, it's x equals positive 3 over 2 times 1. So x equals 3/2. That's the axis of symmetry. And does that look about right? Sure. That'd be right about here, 1.5. If you want to convert this to 1.5 decimals, fine. We need to get comfortable with fractions. I'm going to start using fractions a little bit here. I'm going to leave it in fractions. So let's find the vertex. We said if we want to find the coordinates of the vertex, we're going to need to substitute the x value into the function and evaluate it. So I'm going to do f of 3/2. I'm just going to work this out. So that's going to be 3/2 squared. This isn't work that we're going to need to use, that we're going to do in our head. We're probably going to use a calculator for this. I am. You might delight in doing this by hand, and that would be your prerogative. So once you've shown the substitution, now you can go ahead and use the calculator, and that's what I did here. I'll show you my entry here. Now something weird happens. I want you to be really careful with use of parentheses when you are squaring negatives and when you are squaring fractions. Okay, you definitely want to use parentheses. You could use parentheses all the time if you want, but it's especially important with fractions and with negatives. But something weird occurs here when I hit enter. You're going to see that that parenthesis kind of disappears. The calculator, I guess, knows what it's doing with this fraction. It's going to square it, but it does not show the parentheses. So I just wanted to have you notice that. But do use the parentheses when you're squaring. All right, so the y value, long story short, is 7/4. Back to the drawing board here. So we're going to identify the vertex. Okay, this worked out to be 7/4. And so I can say f of this equals 7/4. And so now we know the vertex is 3/2, comma 7/4. If you want to use decimal, the decimal equivalent would be 1.5 for the 3/2, 1.75 for the 7/4. The y-intercept, well, that's just right here. It's 4, and no coincidence, that's the c value, right? We saw that in the gizmo. When you substitute in 0 for x, that would be any point along this y-axis. That's going to go away. That's going to go away, right? Multiplying by 0. And so you'll be just left with 4. And so the y-intercept is always that c value, that constant. I like to write the y-intercept as a point because it is a point, right? It's not a line. Right? So if I write 0, 4, it's clear that it is a point. Since the parabola opens up, the vertex is the lowest point. So the minimum is that vertex. So the minimum is the point 3/2, comma 7/4. Now let's get into domain and range. Our domain and range, got another version of the graph down here so I can refer to it. The domain of the graph, that refers to the x values. So that's going from left to right. You don't see any breaks in the graph, and it continues forever in the negative x direction and forever in the positive x direction. So we're going to consider the domain to be all real numbers, which we can express as negative infinity to infinity. Or you can just write this fancy R, and that's saying all real numbers as well. The range of the graph. Well, the range does not extend to all y values that exist. It doesn't exist at all down here until you get right there. And so you have to know what that y value is. And of course, that's 7/4. That's the y value of the vertex. So the range starts at 7/4. And we have a square bracket here because it does include that point. And now it continues forever in the positive y direction. The interval where the graph increases in value. Well, it's obviously increasing here once it gets on the right side of the vertex. So it's all the points from 3/2 up to 7/4. No, not 7/4. I take that back. That's not right. Try that again. 3/2 up to infinity in the x direction, right? We know with infinity we always use parentheses. The question is, what do we use on this side? Well, at that vertex, it is neither increasing nor decreasing, right? It's a turning point. So we're going to say that after you pass 3/2, that's where we're going to use a round parenthesis. After I pass 3/2, it is increasing. And on the left side, until I get to 3/2, it is decreasing. So it's decreasing from negative infinity down, 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 down until it gets to the vertex, and then it stops decreasing. But at that point, 3/2, it is neither decreasing nor increasing, so I'll put a parenthesis. Finally, we get into a little end behavior here. What's happening to the graph out at the extremes? If we were going to view this from a bird's eye view here, basically, as x approaches negative infinity, so we're going to the left, the y's are getting really big, right? They're getting close to infinity. And as x approaches positive infinity, f of x, or the y values, approach infinity as well. Okay, so I'd like you to apply all that stuff to do the second example on your own and play the recording when you want the answers. All right, so I'm hoping that you took time to pause, work as many of these out as you think you can, and struggle with it a little bit. If not much learning is going to take place from you just copying down my answers. And that's the whole point, right? It's not getting some notes, it's getting some learning. So what we've got here is an axis of symmetry, which curiously is the same axis of symmetry as before, just a coincidence. And when we sub in, we've got a vertex of 3/2, 0, and we can see that that kind of fits with what we've got here. That is confirmed with the graph right in that point. That is the point 3/2, 0. We've got, therefore, an x-intercept of 3/2, 0, because it's the point where y is 0, where it crosses the x-axis. The y-intercept is always this c value, as we've said, so that's obvious right there. The parabola opening down means we've got a maximum value at the vertex. We do not have a minimum value. It goes on forever in the negative y direction. We've got a maximum value there. Domain and range, well, as you might be noticing, all parabolas that are functions have a domain of negative infinity to infinity, unless there's some restriction on that domain. The range has to do with where the vertex is. So the vertex, the highest point is 0, so the graph goes from negative infinity up to 0, and it includes 0. We can see that. It goes all the way up, includes 0, and then heads back down. Now we get into the increasing and decreasing intervals. So when we look at the sketch of the graph down here, we can see that the graph increases all the way up to the x value of 3/2. So from negative infinity to 3/2, and then it decreases from 3/2 down to infinity. But I have a round parenthesis here because at 3/2, it is neither decreasing nor increasing. Finally, our end behavior, they're both going towards negative infinity, right? And you're going to notice that with parabolas, they're going to both be to positive infinity or both negative infinity. Thanks for watching.